Good morning, afternoon, or evening, cats and dogs. Today's video is going to focus on the lesson 2.1 guided notes on integers and absolute value. In class, we will have already talked about how to add integers. This lesson is a little bit easier for you to do on your own. Adding integers is such a foundational topic that I figured that would be a good one for us to talk about on our in-class days. So this video is going to go over everything in the lesson 2.1 guided notes, which means it might be a little bit of a lengthier video. Let's go ahead and get started. So the first thing I want to define for you is the set of integers, something I've probably already mentioned or talked about in class. The set of integers includes numbers like -3, -2, -1, 0, 1, 2, and 3. And the dot, dot, dot on either side represents that the numbers go on forever in both the negative territory and positive territory. Integers also include positive numbers, negative numbers, and 0, which isn't positive or negative, but integers do not include fractions or decimals. We'll address some fractions and decimals in our next unit, but at this point, we're just talking about where these dots are placed on this number line, where integers lie. 0 doesn't have to be in the center of the number line, it just happens to be on this one. That is an integer. The numbers to the left are negative integers, and notice how we sort of go backwards in a way. A lot of times I'll have students write -1 here, followed by -2, -3, -4, -5, -6, -7. But remember, as we get further away from 0, the numbers become smaller. So -7 is smaller than -1. We'll talk more about integers as we get into our examples. Our positive integers are going to be to the right of 0. And again, as we go to the right, those numbers get bigger. So on a number line, numbers to the left are smaller, numbers to the right are bigger. The first set of questions we're going to talk about are where we need to write an integer for different situations. It does ask us also in the directions to circle the word or phrase that tells you whether the number is positive or negative. I would say that a lot of these guided notes are things you could probably do on your own. Just make sure you're double checking your answers either through watching the video or looking at the answer key for these guided notes. So number one, if we have 600 feet below sea level, that's definitely going to be -600. You don't need a label on that, but it's going to represent a negative integer. The word that tells us this is a negative number or a negative integer is the word below, since we're below sea level. And that's just one example where we would see negative integers in real life. Number two, a temperature increase of 12 degrees. That's going to represent a positive value. Again, we don't need a label on this. I've had students ask, do we need to put a plus sign in front since it's a positive value? You do not need a positive sign in front of it. If it's negative, you need that negative, but positive, you do not. Obviously, this is positive because of the word increase, which represents a positive value. Numbers 3 and 4 I really like because they use terms that we need to be familiar with in real life, like withdrawal and deposit. So in number 3, I have a withdrawal of $48. You have to know what a withdrawal is in a real life situation. And you don't have as much real life experience with this word or this term in terms of money and banking. So let's talk about what it means. If we're talking about a withdrawal in this case, we're talking about taking out or taking away. So if I withdraw money, I might be going to an ATM. If I withdraw money, it means I'm taking money out of my account. Now, it's more money I'm getting in my pocket, but with respect to the bank account, it represents a negative integer, so -48. A deposit, on the other hand, is the opposite. That means to put in. So you might deposit a paycheck. When you get to be probably about 15 or 16 and you get your first job, you might get an actual paycheck. A lot of people get direct deposit where it just goes right into their account so they never see it. But if you get an actual check, you might put it in or deposit it in the bank, which would be taking that check and physically depositing it at a bank or ATM. So this is going to represent a positive value. And I realized I did forget to highlight the word that represented, even though we talked about the negative value here for withdrawal, and here a deposit is going to represent our positive value. It's important to be familiar with these words. Again, while you don't have the same real life experience that myself as an adult might have, it is important to be familiar with them. Number 5, we have a loss of 8 yards. Clearly, this is going to be a negative integer, -8, since loss is going to represent a negative number. Number 6, 50 feet above sea level, of course, is positive 50. And again, the word that represents that it's a positive value is the word above. Finally, number 7, this is one that I put in your notes compared to Math 7. They don't have this one, but a profit of $80. You have to know what the word profit means, and it means extra money that is earned. So businesses, for example, try to earn a profit. So if you are going to sell, let's say, candy bars or something similar to that, I know when I was in high school, that was all the rage was a fundraiser would be selling candy bars. The business or the organization would pay, let's say maybe 50 cents per candy bar, but they would charge people maybe $1 per candy bar so that they could make 50 cents profit on each of those candy bars. Businesses have to do this so that they can earn money, so that they don't lose money throughout their business. So a profit of $80 is definitely going to represent a positive value in this case. It's money that a company wants to earn so they don't go bankrupt. All right. So the next thing here is a writing and math section, which we would normally do is maybe a think, pair, share, or discuss together. But I want you to maybe pause the video and think of some real life situations or just a real life situation that would use negative numbers. Some were involved in some of our previous examples as well. So I'd ask you to take a few moments to maybe jot down a few things in that space provided. It does say to write your response in complete sentences. My results will not be in complete sentences, but if you can do that, that would be great. All right, so what did we say here? I gave a few examples here. I'm just going to take this out of the way. So one example is money. We could have negative values. For example, if we're taking money out of an account, you might accidentally overdraw your account, and then you would be in the negative values in terms of how much money is in your account. Temperature is another good example of when we would see negative numbers, especially during the winter when we have really cold temperatures. Elevation, if we're talking about below sea level, is another really good example. Video games, which a lot of you like to play, the scores for those sometimes will be negative values. And I often will ask students, do you know of a sport whose scoring includes negative values? And golf is a sport that includes negative values for the scoring because if you are at -2, it means you're 2 shots under par. In fact, you want the lowest score in golf as compared to the highest score in most other sports. All right, let's talk a little bit about some inequalities. So for these 4 questions we have here, it asks us to write 2 inequalities using the numbers in each sentence. Use the symbols less than or greater than. We have to remember our inequality symbols. So the first one here is our less than symbol, and the one below it is our greater than symbol. You have to be familiar with those. You're in 7th grade now. I know that in elementary school, your teachers probably taught you something about an alligator or crocodile eating the bigger number. If you want to think of it that way, that's fine, but you shouldn't just be telling me, hey, it's the thing that points that direction or points this direction. You need to know that this symbol right here in this direction represents less than, this symbol represents greater than. So we're actually going to use both inequalities in each of these questions. So number 8, 15 feet is taller than 8 feet. We could write 15 is greater than 8, but we can also write that 8 is less than 15. So we can kind of flip this entire thing around. If we do that, we have to reverse everything. So 8 is less than 15, and 15 is greater than 8. Number 9, a gain of 12 yards is more than no gain. So one option we could write is that 12 is greater than 0, 12 is more than 0, no gain. Or we could write 0 is less than 12, so that's another option. Number 10, we've got some negative values here. A temperature of -8 degrees Fahrenheit is colder than a temperature of -4 degrees Fahrenheit. So we could write -8 is less than -4. We could also write that -4 is greater than -8. So let me slide that over. Good. For number 11, it's a good idea here to first figure out what each of these are equivalent to. The absolute value of -10 is 10. The absolute value of -15 is 15. So I'm going to write it using the absolute value bar since that's what is originally given to us. So one inequality we could write is that the absolute value of -10, which is 10, is less than the absolute value of negative 15. And we could also write the absolute value of negative 15 is greater than the absolute value of negative 10, since 15 is greater than 10. But again, I do like to write the numbers that were originally given in the problem. It doesn't matter which order you write the inequalities themselves, so this guy doesn't have to be on the top and this on the bottom, as long as you have two inequalities to represent this situation. This is just giving us a really good introduction with inequalities that we'll see a lot more of later on. All right, let's keep moving. So taking a look next at absolute value. We saw this in the previous question, so I kind of gave you an absolute value question before introducing it in the notes. That happens sometimes. But absolute value is the distance a number is from 0 on the number line. In fact, I'm going to highlight that. So it represents the distance a number is from 0 on the number line. The absolute value of a number is always greater than or equal to 0. Now, don't assume that that also means that any problem that has absolute value in it has to be positive, because there are problems that involve absolute value that do have negative solutions. For example, the absolute value of 2 minus the absolute value of 8 is 2 minus 8, which is negative 6. So that problem involves absolute value, but has a negative solution. The double bars that you saw in that last question are used for absolute value, and we treat them like grouping symbols in the order of operations. We introduced them in our last unit. So for example, if I have the absolute value of negative 5, that's 5. Why? Because negative 5 is 5 units away from 0 on the number line, as we can see right here. The absolute value of positive 5 is also 5, because that number also happens to be 5 units away from 0. So just to make it a little bit of a hint here for figuring out what your solution is, if you're taking the absolute value of a negative number, it makes it positive. If you're taking the absolute value of a positive number, it stays positive. It doesn't become negative, so be careful. Again, if you feel comfortable working on 12 through 18 on your own, and then just checking them with the video or the answer key, that's fine. I realize this is a pretty easy lesson, which makes it really good for just, hey, watch this video, take the guided notes, and of course, if you have any questions, bring them to class. So number 12, we have the absolute value of 10, which is 10. Pretty easy, since 10 is 10 units away from 0 on the number line. Number 13, absolute value of negative 25 is 25, since negative 25 is 25 units away from 0. Number 14, we have the absolute value of negative 4 minus absolute value of 2. Absolute value of negative 4 is 4. Absolute value of 2 is 2. Take 4 minus 2 to get a solution of 2. Remember, if I'm going too fast, feel free to pause the video at any point. Number 15, the absolute value of negative 6 is 6. Absolute value of negative 7 is 7. Add those together to get a solution of 13. Number 16, absolute value of negative 10 is 10. Absolute value of negative 3 is 3. And of course, 10 minus 3 is going to get us 7. So easy peasy questions. You've probably seen absolute value before as well. 17 and 18 are a little different. So I've got the negative absolute value of negative 18. The absolute value of negative 18, this part that I'm going to highlight here, is positive 18. But you have a negative sign outside the absolute value bars. So my solution here is going to be negative 18. Which is why I said that even though the problem maybe involves absolute value, the final answer doesn't have to be negative. Or doesn't have to be positive. It could be negative. Got to correct that there. It's a Friday, for me at least. Number 18, we've got the negative absolute value of 10. So the absolute value of 10 is 10. We've got this negative sign right outside the absolute value bars. So we just pop that right in front. And this solution will be negative 10. Oh, I hope you cannot hear my toddler screaming upstairs. I think he wants to do a puzzle right now. All right, so let's continue with the examples. I didn't put a lot of independent practice in here because as my pre-algebra students, I know that you probably don't need a lot of independent practice on this. So let's keep moving through this. These questions ask us to replace each blank with less than, greater than, or equal to make a true sentence. So negative 19 and 18. Negative 19 is certainly less than 18. So we've got our less than symbol. The most important part here is recognizing your inequality symbols, which you need to know. If you're in my classroom, there is a poster on the wall that has the inequality symbols on it. Usually I try to remember to cover it before a test or a quiz. Sometimes I forget though, so look around for it when you're in the room. Number 20, negative 45 and negative 61. Now, if these were positives, 45 would be less than 61, but as negatives, negative 45 is actually greater than negative 61. So again, I like to think of them as positives and say, well, I know 45 is less than 61, but I got to flip that around when they're both negative. Number 21, 0 and negative 5. 0 is definitely greater than negative 5. Number 22, negative 10 and negative 8, very similar to question 20. Negative 10 is less than negative 8. One of my children is stomping around upstairs. Number 23, the absolute value of negative 19 is 19. I'll actually type that in right here. And 19, of course, is going to be greater than 16. So we've got the greater than symbol. Number 24, the absolute value of negative 14 is 14. The absolute value of 6 is 6. And 14, of course, is greater than 6. Slide that up there. Number 25, the negative absolute value of negative 12 is negative 12 because of that negative outside. 12 is just 12. So negative 12 is less than 12. Number 26, we have that negative absolute value of negative 12 again, which is negative 12. So if I'm comparing negative 12 to negative 12, most certainly these guys are equal. All right, moving right along. So numbers 27 and 28 ask us to write these numbers in order from least to greatest, very similar to what we already saw. So number 27, our smallest number is negative 8, followed by negative 5. Then we go into our positives, which are super easy. That's going to be 0, 6, and 12. Number 28, all of the numbers are negative. Negative 21 is our smallest, followed by negative 15, followed by negative 12. And it looks like we're almost going to go in order from right to left up here, but negative 9 comes next, followed by negative 7. Again, these are ones I'm going through quickly since I know that every year when I do these with pre-algebra students, they can just coast through these notes. All right, next question here is not in the guided notes, but this is a really important one for us, so pay particular attention to this. Because if I remember correctly, on your mid-unit quiz, you have something similar to this question. It says there are two solutions to the equation, the absolute value of x equals 3. What are the two solutions? Pause the video and think about that. All right, did you come up with the two solutions? One of them is 3. The absolute value of 3 is surely 3. But the absolute value of negative 3 is also 3, since both numbers, negative 3 and 3, are a distance of 3 units away from 0. I did have another question here as well. It says, what is the solution to the absolute value of x equals negative 3? What do you think? If you're thinking, I don't know any number whose absolute value is equal to negative 3, you're correct. Because the absolute value of 3 is 3. The absolute value of negative 3 is also 3. There is no number that when you take the absolute value of it without having anything outside the absolute value bars that will equal negative 3. There's no way to take the absolute value of a number and get a negative solution. You'll talk a lot more about absolute value equations and even inequalities in algebra next year. All right, let's get back to the guided notes. So 29 through 32, I'm going to go through these quickly. They're evaluating questions. And let me remind you that evaluate means get a number answer. So you should not just be plugging the numbers in. You also want to find the solution. So number 29, we've got 16 plus the absolute value of c is 16 plus the absolute value of negative 6. The absolute value of negative 6 is 6, and of course 16 plus 6 is 22. In number 30, we have the absolute value of A minus absolute value of C. So this is going to be absolute value of 12 minus absolute value of negative 6. Absolute value of 12 is 12. Absolute value of negative 6 is 6. We subtract these guys, and we're going to get 6 for our solution. Number 31, we have A and B squished side by side, which means we need to multiply. So we have the absolute value of 12 times 5 plus, once again, the absolute value of negative 6. 12 times 5 is 60. So I have the absolute value of 60 plus 6, since the absolute value of negative 6 is 6. The absolute value of 60 is 60, and 60 plus 6 is 66. All right, too many sixes. Number 32, we see it again, the absolute value of negative 6 plus 12 times 5, that's AB, plus the absolute value of negative 10. Absolute value of negative 6 is 6, 12 times 5 is 60, absolute value of negative 10 is 10. Add all those guys together, we get 76. So hopefully those were pretty easy for you. As pre-algebra students, I expect those to be relatively simple problems. All right, moving right along. Now that we're at 20 minutes, we want to try to keep this around 30 minutes or so. So these next two questions don't seem too difficult, but I have seen students make mistakes with these in the past. So it says to graph each of the following sets of integers on the number line provided. The first thing you need to do, your number line does not have these little tick marks in there. You don't have to have as many as I have. I actually have some extras. But in number 33, for example, I need to go from a lowest value of negative 3 to a highest value of 6. Mine actually goes up to 9, so I have some extra lines, but you need to have a minimum of that number of tick marks so that you can fit negative 3 all the way up through 6. In number 34, we have to go from a minimum of negative 5 all the way up to positive 4, so that's just something to keep in mind. So in number 33, I already have my numbers ready to go, and I put the tick marks in there to save some time. My smallest value is negative 3, so I'm going to slide that in. That's going to go all the way on the left, followed by negative 2, followed by negative 1, 0, and you'll be writing these, so you'll actually probably be a little quicker than me. 1, 2, 3, 4, 5, 6, 7, 8, and 8 and 9. There we go. Now, what I want to do is at the positions where 0, negative 3, and 6 are, I want to slide one of these dots up and I want to put it right over that. I can actually put it right on the number line. Sometimes students have them hovering up above. I'm not sure where that comes from. Just put them right on the number line. So a dot at 0, a dot at negative 3, and a dot at 6. And we are done. That's all we have to do. Now, I've had students ask, can I count by twos? Can I count by threes? You can do that. I just chose to count by ones here. Just count by whatever makes the most sense. In this one, counting by threes is not a bad idea, actually, as long as you label those numbers down below. So in number 34, looks like my smallest number I have is negative 5. So I'm going to bring this guy up. So I've got negative 5, negative 4. There we go. Negative 3, slide that in there. They're going to be squished together a bit. Negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, and 7. This one, because it has both odd and even numbers, it may be a little harder to count by twos or threes or anything, but you can kind of estimate where some of those numbers are. I like to count by ones, though, in most cases, as long as they're not really spread out. So I need to have a dot at negative 2. Let me slide that up here. A dot at negative 5 right there. Try to make sure your tick marks are equally spaced. Mine are pretty close, but they are not perfect. That's okay. I'm not going to pull out a ruler and measure, but try to keep them as equally spaced as possible if the space between your numbers is equivalent. We need a dot at 2 and then a dot at 4. And we're done. It's as simple as that. Things that I don't feel like we'd have to go over as a class, but I've seen some really wacky things that students have done with these, including I have seen students put stars above the numbers. I've seen them like circle the numbers. I've seen them draw arrows to the numbers. I'm sure you could come up with all sorts of crazy things that students might do. Just put dots on the number line. I know that math is not super exciting. It's not really for the creative minds, but try not to go too crazy here. So number 35, I actually think is kind of a silly question, but I asked a question like this on a test a few years ago or a quiz, and students were like, I don't know how to do this because they hadn't seen a problem like it in their guided notes. So number 35, name the coordinates of each point graphed on the number line. So A, I'm going to put a colon after this so that it doesn't look like a negative, is at 0. Pretty simple. B is at 2. C is at 6. D is at 3, and E is at -4. It is as simple as that. Easy peasy. All right, we're almost there. So number 36, Maya is asked to graph the following set of integers on the number lines. Take a look at that set of numbers. Why is her response, which is shown below, incorrect? Pause the video, think about it, and jot something down. So I went really thorough with my explanation here. I said here, there are several mistakes that Maya made with this question. First, she has no dots on the number line to represent the numbers in the set, and we do need to have dots on that number line to represent the numbers that are in the set. You can't just put the numbers that are in the set on the number line and say, oh, I'm done, they're there, these are the numbers. Also, while she has them in order from smallest to greatest, she didn't include the other integers between, for example, -3 and -1, and those between -1 and 2, which if I'm counting by ones up here, I need to be consistent the whole way through. So you can't start counting by 2s and then count by 3s and then count by 1s. You need to be consistent the whole way through there. I also want to point out that the space is the same between all of the integers shown above, but there should not be an equal distance between these numbers because really there's a distance of 1 unit between 2 and 3, but there's more of a distance between -1 and 2 and then -3 and -1 as compared to between 2 and 3 and 4. So that's also something to consider. But I have seen students do this before. They're like, oh, here's my numbers. I'm going to put them in order, stick them on the number line, boom, I'm done. No dots or any of that. Please don't do that. Go back to these problems. Make your number lines look like these. Look at that. It's a thing of beauty. All right, we are almost done. Let's get through our last 2 questions so Mrs. Garcia can enjoy the rest of her weekend because it is a Friday for me. So number 37, it says to evaluate the absolute value of -5 plus 2. Whoa, double absolute value. You're in pre-algebra. You're expected to be able to do double absolute value. So let's start with the innermost absolute value because they are grouping symbols. The absolute value of -5 is 5. So I'm going to keep those, I'm going to keep those grouping symbols here around the 5 plus 2, but I'm going to do 5 plus 2 next. That's going to get us 7. And then, of course, the absolute value of 7 is 7. Pretty easy, but it does involve double absolute value. Number 38, similar problem. Start off with the absolute value of -12, which is 12. Do 12 minus 5, which is 7. And just like the last question, the absolute value of 7 is 7. All right, so I know it's kind of a lengthy video, but I wanted to do this entire lesson all at once because I know it's a pretty easy lesson for my pre-algebra students. So hopefully you got something new out of it, if it was double absolute value, if it was reviewing inequalities, if it was graphing numbers on the number line, if it was working just with absolute value in and of itself. Hopefully you got something out of this. If it was all easy, that's great. We'll be seeing some more challenging and more difficult things this unit though, so be ready for that. I appreciate you listening and have a great day. We'll see you with the next video.